So as I was saying, I said I will show you how to reallocate terms, simplify and clear x. So imagine in an equation like 2x plus 5 is equals to 10x minus 3. Now this is a equation. To allocate equation, you collect like terms. This one will come to the side. The 10 will come here. The 10 will come and meet 2, and the sign will change from positive to negative. The sign will change from positive now to negative because it's a positive 10, and this 5 will go to meet 3, and it's change to negative, and it will be like this now. It will be 2x minus 10x equals to minus 3 minus 5. And you know that here will be what? Here will be minus 8x equals to minus 3 minus 5 is what? So my minus 3 minus 5 is equals to minus 8. So now equals to minus 8. Minus 3 minus 5 equals to minus 8. And minus 3 and minus 5 is equal to minus 8. So now to clear x, I have to divide both sides here by minus 8, here by minus 1, minus 8. This goes, this goes, this goes, this goes. So you know your x is equals to 1. There's a simple thing to clear x. Now I've simplified it here. First of all, I allocated it, then here I simplified it. Then now I actually cleared x down here. That's what I actually did. That's just the simple thing I did here. So there are some practical examples in solving first degree equations. There are practical examples you must actually know. As examples to find first degree equation and solutions, there are practical examples to actually find it. So I actually solved it down already, and I will explain it step by step to you. So now this is our equation here. Sorry for the shaky, because I'm doing it by myself, so everything is just shaky. Sorry for that. So this is our equation here. This is the first time I'm doing something like this for somebody, like a pre-recorded video. It's our equation here, our equation. So now using the steps I showed you in the other video, in the other part of the equation, using these steps, the allocating of terms, simplifying and clearing x. I'm going to use that steps to solve this equation. First, now we are allocating terms. I also told you it's called collecting like terms. What we did here was this. This is our equation. 4x plus 2 equals to 14x minus 2x. First, what will you do? What will you do here now? You collect like terms. This 2 that's negative will cross to the other side and become positive, and this 2 that's positive, these 2 are positive here will cross to the other side and become 1 negative. This is what just happened here. It's a question of like terms. The ones with x comes together and the ones without x comes together. So that's why this talk come and say the 4x will leave it as it is. We leave the 4x, this 4x here, this 4x here as it is. We will not touch it, and the 2x, that is the restando. This one, the one coming towards to meet this one, passes addition to the first member. So this one now will carry itself with an addition sign and come and meet this other one. That's what we actually did here. So this 2x will now move to come and meet the 14, and this one goes to meet this 4, and this 2 goes to meet the 14. That's what we actually did here. And the next thing in the steps was to simplify. We simplify. How do we simplify now? Now we actually solve now for. Now these 2 are common. So 4 plus 2 is what is 6x, and 14 minus 2 is what is 12. That's what we actually did here. Then 14 minus 2 is 12. Hope you saw it. 4 plus 2, that's simplifying it, is 6x, and 14 minus 2 is what is 12. Now to clear x, we clear x by dividing both sides by 6. So you see 6x divided by 6 equals to 12 divided by 6. So x equals to what? 2. That's how you clear x. You clear x by the this thing coefficients that is attached to the x. To remove x, we divide both sides by the coefficient of x, and that is what? That is 6. As to clear x, divide both sides by the coefficient of x. The coefficient of x here is 6. We're dividing both 12 by 6 and 6s by 6. So now, next part now. So I told you that time that when equations are not yet simplified, they will be in parentheses, they will be in brackets, and they will be in fractions, and they will be in denominators. So this is now how to solve first degree equation in parentheses. It's just you solving it. It has its own distance steps. First of all, before you start solving anything, before you start reallocating terms, simplifying or clearing or you want to clear x, what you do first is remove your parentheses, and then you reallocate your terms and simplify, then you clear x. So this one example. This one example here we're using. There are more complex examples. So the further we go into this video and the further the class proceeds after today, if you like the video, you like the way I'm doing it, so the further we go into the class, the further you get to see more things, more complex things on first degree equations. These are just the easy part of it. So as the further we go, I also want to use this and make you understand how it looks like, what a first degree equation is. Maybe the next time we'll meet, maybe before I round up the video, I will touch some things on inequalities in one variables, so you just get an idea of what inequalities in one variable is before we move forward. But this is just an easy part of what you're going to do. So I'm just showing you these ones to just get your mind prepared and at least know the steps involved in all this. The steps involved, steps we're going to take in doing all this. So now this is an example now how to solve first degree equation with parentheses. These are our parentheses. This bracket are parentheses. So now this is our equation here. 10 plus 2 open bracket x plus 1 equals to 4x minus 4 open bracket 2x minus 2. That's 2x minus 2. So now you know this 2 is with this bracket here. These two, they are all together. These ones are all together, and this 4 is all together with this one. So what just happened here was that this 2 times this x, 2 times s is what is 2x, and that's what is here. Then 2 times 1 is 2, and that's what's here. That is clearing. We have cleared what the first parenthesis, that's the first bracket. Now go to the other side of the equation. This 4 is with this ones here. 4 times 2x is what is minus 4 times 2x is what? Minus 8x. And minus 4 times minus 2 is what? Plus 8. That's what just happened here. You just multiplied the outside, what's outside the bracket with what's inside the bracket, and this was outside the bracket. We multiplied it with what is inside the bracket. That's why we got this. So automatically now we have actually moved the parentheses. We have actually moved the parentheses now, officially now, from this whole equation. Now the next thing to do is relocating terms. Now I want to locate terms here now from this place here, from here. I want to locate the terms. What we do now is this: bring every coefficient carrying x, every number carrying x to the others to one side, that is to this side. Every number of that x to this side. So now look at it very well now. 4 and 8 having x, so they are going to move to this side. Then 10 and 2 are not having x, they are going to move to the other side. So 2x minus 4x plus 8, because when this minus 8 comes here, it becomes positive 8. When this positive 4 comes, it becomes negative 4. When you move numbers from one side of the equation to the other side of the equations, the signs in front of them changes. And you know, instead of front of this one is a positive sign, but we don't write positive sign there because there's no need. Instead of this one sign for this one is a negative sign. So when it's moved, everything changed here. It became positive, became negative. Same thing applies here also. The 8 remains, positive 8 remains where it was. When this 10 moved here, 10 became negative, because 10 was positive. When this 2 moved to the other side, became negative also. So you understand now. So now the next thing there is simplifying. How can we simplify now? This is 2x minus 4x plus 8x. If you punch that in your calculator, you ought to get is 6x. And when you put 8 minus 10 minus 2, when you put that calculator, to get is minus 4. That's what I just did there. Just summing all this stuff and summing all this stuff, and we're getting the answers here. So now we're going to clear our x now by dividing both sides by 6, because that is what you have to move the coefficient attached to x to make x stand on its own, and that's what we're going to do here now by 6 now, and this is it. So we're having here 6x over 6 equals to minus 4 over 6. So automatically this one will cross out and x will be on its own. X equals to this. Now we simplified it further by dividing both sides by 2. If divided by 2 you get 2, divided by 2 you get what? 3. So now our x now is equals to what? Minus 2 over what? Over 3. After we simplify further. Now in this case, you know, you can't simplify any further again. You have to simplify till you can't simplify any further. At this point, you can actually stop if you don't know what's next to do. But in cases where, in objective cases now, where they'll give you give you questions and the answers will be in this form, you have to simplify harder. So that's why we have to simplify it again. But if it's in theoretical form now, where you have to solve and give an answer, you can actually stop here and get a full mark. If you stop here, you can actually get a full mark. But if you stop it, you can get the same mark. But in objective cases, this may be the answer I'll put there. This may be the answer I'll put there. And if you don't get this answer, if you don't simplify this thing further, you can end up missing this answer. You can end up failing it. That is just it. So this is another example of removing the parentheses. I did 2 examples for this ones because there are different. There are more examples, but the further we go, the more you see it. You see more complex examples where you see parentheses, fractions, denominators all together in one equation. So this one is are parts. I'm picking them parts from an equation. This is just parenthesis time now. After you reach where, like, when I'll show you examples of this, of an equation of this is what an equation looks like when it's not simplified. This is a fraction. This is a fraction. This is a parenthesis. This is a fraction. This is a denominator. This is a parenthesis. This is a fraction. So you see, when you go deep into this first equation, you find out that that's why you now start seeing them adding everything together. So you must first know how to solve it part by part. So when you see an equation like that, you know what to do first. So now, for this now, if you are moving the parentheses, and by doing that, the only thing you're going to do here, this minus is going to go through everything inside this bracket. This minus here is going to go through everything inside what? Inside this bracket. Here so to be what? A positive 5. That's going to be positive, because when minus 3 times 4 minus times 4 is minus 4. The minus times 5 is what? Is plus 5. As equals to this. That's what is here. Then you allocate terms. this one will come to meet this, it's not minus, this point to be plus. This one has got to meet this one here to make it what? To come to meet this one here. This one here is going to meet this one here. And these two are coming towards the side here, towards the other side. You understand? This was here before, was at the other side of the bracket before. It came to meet the 5 here. So it was positive here before, then became what? A negative when it crossed to the other side of the equation. Hope you get. So equals to all these ones here. This 4 was positive, it meant for this positive. This 3 was positive, it became negative, and this 4 was negative, it became what? Positive at the other side. That's what it is. So when we simplify further, when you simplify this, you get minus x. When you divide that, what you get? You get minus. When you divide that, you get minus x equals to what? Equals to 5. And to clear this now, you have to divide both sides by minus 1. Wherever you see minus here, just know that it's 1 that's standing here. 1 times x. Minus 1 times x. That will give minus x. So divide both sides by minus 1. Divide by minus 1. If you divide both sides here by minus 1, here by minus 1, you automatically, this minus will go. And they will be like this. So your x will be equal to anything is power. X on anything where anything that is divided by 1 is that same thing. So you see, x now becomes minus 5. The minus come and meet this what? The x, the 5. That's what has happened there. Hope you understand. Normally, in normal cases, you can actually stop here. And you actually proceed down to this place here. This is me, this Kingsley Thompson from Nigeria, Abuja, precisely. This is the first time I'm actually doing any online video for anybody. I'm not that good at online videos, pre-recorded videos, because I've not done it before. That's my first time. So I just hope urge you to endure with every little mistakes I make in my talking, in my videoing, and so on like that. I can't have your accents. Your accent is far different from my own accent, but just try and manage what I have. The reason why I did it, I wrote it out first, so it would be easier for me to actually record and talk. So tomorrow when we are doing the video call, I'll be able to explain further for you, and at least video call, I'll be videoing paper. You've seen how I'm solving it. I'll be solving it at the same time as I'm videoing it. I'll be seeing how I'm solving it, and it'll not be that difficult like that. So just bear with me. Thank you. So now we are heading to the next part of the video, and that is how to solve first degree equation with denominators. And that's actually where I stopped today, sir. Then I will now, because I don't want to stress your brain. So let's take it gradual. It should be a gradual process. So how to solve first degree equation with denominators. I wanted to go into how to solve first degree equation using fractions also, but as let me leave down for another day. Maybe tomorrow when we are doing the video call, I will bring that up and I will show you how to do that also. So now, first of all, what you do is to remove the denominators. After removing the denominators, next thing you do is remove the parentheses, then you allocate the terms, then simplify, then clear x. Now examples now. This is 3x plus 1 all over 2 plus 1 plus x all over 6 equals to 7x plus 4 all over 4. Now removing the denominator first by finding the LCM. 2 times 6 is 12. Two times 6 is 12. And the total denominator here now, 2 times 6, 2 times 4, 4 plus 4 is is 8 plus 4, that is 12. 12 times 2 is what? Is 24. So if you times everything there, your total distance will be what? Will be 24. So we divide through by what? 24. So this is it. These two are together. These two are together. This one is on its own. So now we have to remove the denominator. That's when we put, that's the 12 that is up here. That's the 2 times 6, that is 12. And like that, to remove the denominator out of the whole equation. So we times 12 by all this, times 4 by all this, times 6 by all this. So you cross out the two denominators to evict the denominator. That's how you remove the denominators. Then after removing the denominators, then you remove the parentheses. You know how to move. I've showed you how to remove the parentheses. Everything here, if they get to this 4 times everything here. This one is the parenthesis here. Also, parenthesis here also. So you know, like that, and that is how 12 times 3 will give us what? 12 plus 12 is 24. 24 plus 12 is what? Is 36. It's 36. Then 4 times 1 is 4. And 4 times x is what? Is minus 4x. 6 times 7, like that. So removing parentheses now. Removing parentheses. Now you're seeing that 6 plus 12. That is our, when you go back to equation here, equation here, because 12 times 1 is 12. That's what got this 12 form. That is x plus 12 plus 4 minus 4x equals to 42x plus 24. That is for our 6 times 7x is for 2x. Our 6 times 4 is for 24. Now if we allocate, because now if you come back here, you see here very well. 6 times 4 will give us what? 24. And all three of them here also give us what? 24. So that's why if you see they generally use 12 and 4 and 6. Because 24 in 2 will give us 12. 24 in 6 will give us what? 4. And 24 in 4 will give us what? Give us 6. That's how we got all these things here. 24 in 2 will give us 12. 24 in 6 will give us 4. And 24 in 4 will give us 6. So that's when I remove the parentheses, you know how to make parentheses, multiply everything, and you've gotten your parentheses. Now this is to allocate terms, bringing all the x term to one side and the number term to the other side. And that's what we did here now. I've done that one here, right here. So after that, we simplified. If we now do 10x minus 10, when you sum all this stuff, when you sum of them, what you get is minus 10x. And when you sum all this, what you get is what? Is 8. So when you want to clear x, divide both sides by 10, minus 10x. Divide both sides by minus 10x. The minus here, 10x. So this is minus 10x over minus 10 is equals to 8 over 10 over what? Over minus 10. 8 over what? Minus 10. I'm a perfect teacher, so that I make slight mistakes. But the more as I'm explaining it, I will correct my mistakes. So now, this 10, we cross out this 10, leaving x on its own. And this 8 here, and this 10, you can leave your answer as 8 over minus 10. But I told you in objective cases now, if your answer now falls, I have to break one more further. You go 2 here, will give us what? 4. And 2 here will give us what? Minus 5. So that is what is here. So x now equals to what? X equals to what? Minus 4 over 5. That's what our x will become. That's our x answer. You can't bring this one any further. What can go to 4 and go to 5 without reminders? Nothing. So this will be our final answer. This one. So that will be our final answer. So I'll be using this net now. This is actually one of the materials I'm using. So I'll try to explain the linear equalities in one variables. So first of all, learn the objectives, use addition, multiplication properties to solve algebraic inequalities, solve linear inequalities, and express solution with intervals, notation, and give an inequality. Simplify and solve algebraic inequalities using the distributive properties. Now, using the properties of inequalities now. First of all, they said we are talking about inequalities in one variable. So this one is a linear inequality because it's only what one variable. When it's dealing with two variables, one guy a linear inequality, the inequality against that's what a quadratic inequality because it's dealing with two variables. But now it's a linear inequality because it's dealing with only one variables. Also using the properties of inequalities. When we work with inequalities, we can usually treat them similarly but not too exactly as we treat equalities. That means equality means equations. We can treat inequalities, but not the same way as we treat equations. We can use the addition properties and the multiplication properties to help us solve them. The one exception is when we multiply or divide by a negative number doing a reverse, doing a negative number, doing so reverse the inequality symbol. So it's just different from what we'll be doing actually. Totally different from what we'll be doing when it comes to for inequalities. Like is the opposite of equalities. Inequalities like the opposite of equalities. So now when you divide or subtract a number, it changes the sign of inequalities. These are properties I'm meant to know in inequalities. Properties I'm meant to know and the signs I'm meant to know in inequalities. And now these are general properties of inequalities. You have the addition properties, you have the multiplication properties, like that. If A is less than B, then A plus C is less than B plus C. That's what it means. So tomorrow when we have to do the video call, just take my attention back to this part and I will give you some practical examples of what it means here. And for multiplication properties, if A is less than B and C is greater than 0, then AC is less than what? BC. So if A is less than B and C is less than 0, then AC is greater than BC. So tomorrow just bring my attention back to this place. I'll give you some practical examples of what this whole thing here means. So since it's actually my own local material I can find, so I just got this on the net, and because I was not planning to take you on inequalities today. I was planning to tell you on the first degree equation, which is also known as linear equation. So, but since there's still time, I may reach the 1 hour, so let me just continue explaining some things. Okay, now we start with A is greater than B, multiplied by C, final inequality what AC minus what BC. It's just easy, it's just as easy as this. I'm coming. What is actually saying is that what this stuff is actually saying is this. We give you your A is greater than B. It's like more like equals to C. That's what it just looks like. So your A is times C and your B multiplying C. You're like A C is less than B C. That's what this place here is just telling us about there. So that's what actually applies when they give us what 5 is less than what? 5 is less than 3. multiplied by 3. That is 5 times 4. 5 times 3 here will give us what, 15. And 3 times 3 will give us what, 9. Then go down here also. A is less than B minus C. So when you times anything by this stuff, you get negative sign here. So you see the sign changes here. The sign changes here. If you notice, the sign changes of what? Negative. It's become negative sign at front of it. So the sign what changes. Same as applies here. Again, said 5 is greater than 3. When you multiply them both, you notice that the sign changes. I'll tell you about the reverse equation. When it's multiplied by a negative number, the sign in the middle changes indirectly. So when it comes to division again, it's just a simple thing. A less than B divided by this. You divide both sides by it, the sign will not change. But when a negative sign just comes in place, all signs or changes. That's what it actually means. So now these are examples to demonstrate the properties of addition. So these are like some properties. This thing of addition. You're seeing x minus 15 less than 4, then 6 greater than or equals to x minus 1, then x plus 7 is less than what? It's less than 9. So now there are like some examples to try out.